Hello everyone. In the last session from chapter number 6, that is space segment, we have seen 3-axis stabilization and spinning stabilization. Now, in this session, we will cover requirement of attitude control system, thermal control system, and what do you mean by TT&C, that is telemetry tracking and command. Now, what is the requirement of attitude control and the orbit control system? The main reason is, as we are offering attitude and the orbit control during a launching phase as well as in the operational phase of the satellite in such a way that to correct the specific orientation of satellite as well as to make sure its orbit should be a stationary. Okay, so orbit control is required to correct for the effect of perturbation forces. This perturbation force effects from sun, moon, as well as the gravitational force of the earth, right? So during the launching phase, the control system maintains the correct altitude of the satellite. For example, if it is used to maintain the link with the ground earth station, then it controls its orientation in such a way that satellite it is in correct direction for an orbital maneuver. So when the satellite is in the specific orbit, the attitude control system maintains the antenna of the satellite, which is pointed accurately into the desired direction. So the precision with which the attitude needs to be controlled depends on satellite antenna beam width. Now, what do you mean by beam width and what is the relationship between the beam width and directivity? So beam width is inversely proportional to the directivity. Why? Because as beam width is going to be increased, that means its directivity is going to be decreased. So for higher gain antenna and if highly directional antenna, the beam width should be a narrow, right? So the spot beams and shape beams require a more precise attitude control as compared to earth coverage or regional coverage antenna. Why? Because a spot beam has a narrow beam width, that means high directivity. Okay. Now, what do you mean by thermal control? Thermal control means it is required. Thermal means temperature. Why we need to control the temperature of satellite? The first reason is sun's radiation. All right. Second point is the thermal radiation from the earth. And the third reason is equipment in the satellite. First of all, we know that in satellite there is an amplifier, mixture, and different components are there. Apart from that, solar cells are there. Okay. So as number of components are going to increase, it will cause also increase in the heat produced by that component. Okay. So overall heat of the satellite is going to be increased. So we need to control the temperature of the satellite. So how we can reduce the temperature or minimize the effect of temperature on the satellite? So the first point is thermal blankets and the shields may be used to provide the insulation. And the second reason is radiation mirrors are often used to remove the heat from the communication payload. Now, what do you mean by telemetry, tracking, and command system? TT&C is abbreviation of telemetry, tracking, and command. Now, what is the function of TT&C system? It supports the function of spacecraft management, which are used for successful operation of all the satellites. So it can be treated separately from the communication management. So as its name includes telemetry as well as tracking and command. Now, what do you mean by telemetry? What do you mean by tracking? And what do you mean by command system? The command system is basically used to command the satellite to maintain its specific attitude as well as the orbit. Then this command is going to be given from the Earth station to the satellite with the help of communication link, okay, to maintain its orbit as well as its attitude. Now, what is the function of TT&C system? The first point is it monitors the performance of all the satellite subsystem and transmit the monitor data to the satellite control center. Second point, it supports determination of orbital parameters. Which parameters? We know that there are total 6 different orbital elements. All right, as well as we have already studied different orbital parameters. The most important is apogee, perigee, argument of perigee, eccentricity, semi-major axis, as well as true anomaly and mean anomaly, right? So we have to determine what are different orbital parameters, as well as it also performs and monitoring the different performance of satellite subsystem. And it also provides a source to the Earth station for tracking. Why we need to track our satellite? Because we are every time calculating what is the azimuth angle and what is the elevation angle. Based on that, we are able to find out the antenna's loop angle in such a way that my satellite will always pointed towards my Earth station antenna. Okay, as we have studied, there are two different types of antenna look angle. One is azimuth, second one is elevation. Azimuth means horizontal, elevation means vertical angle. Okay. The fourth function is it receives the command from the control center for performing a various function of the satellite. So it also transmits the command, receives the command, it monitors the performance as well as it determines the different orbital parameter. Apart from that, it also tracks the satellite, tracking in terms of measuring azimuth angle and elevation angle. Okay. Now, first of all, we are focusing on telemetry subsystem. What is the use? We are separately studying telemetry, tracking, and command. First, telemetry subsystem. So telemetry subsystem is refers to the overall operation of generating an electrical signal proportional to the quantity being measured, encoding and transmitting to this signal to the distance station, or you can say earth station. So first of all, what is the function of telemetry subsystem? It generates the electrical signal, encode it and transmit to the longer distance. So what this data includes? This data includes the attitude information, that means correct orientation of satellite. Second, environmental information, that means magnetic field intensity and the direction, frequency, like that, as well as atmospheric information like whether is rainy or not. Okay, because rain attenuation will also degrade the quality of our information signal that we have discussed. Okay, Third one, spacecraft information. Spacecraft information is related to the temperatures, power supply voltages, and stored fuel pressure. So these are the data which a telemetry subsystem will going to transmit in terms of electrical signal, and also before transmitting it encodes it, and then it going to transmit to the earth station. Now this is the block diagram of telemetry system. We can see over here that sensor output. Now which sensors will be there determines the temperature, moisture, that means the weather related information that we will get over here. Okay, but that sensor output is in terms of analog, so it is going to be converted into digital signal by analog to digital converter. Then we are going to format it again. As we need to transmit it the longer distance, then we have to use the modulator. And the last portion is telemetry transmitter, that is going to transmit our signal through this telemetry antenna. Now these data ranges are in terms of 150 beats per second, or you can say 100 to 150 beats per second. So this telemetry signal is commonly used as a beacon by a ground station for tracking. Okay. Now, as I have told you that telemetry transmitter will not transmit the signal directly, it first encode it. So digital encoders are locked in each subsystem of the satellite, and data from each encoder are located in each subsystem. So this data from each encoder are sent to the central encoder via a common line, or you can say time shared bus. Okay, why? Because it reduces the number of wire connection and also permits the easy expansion of initial design and facilities testing during the assembly of satellite. Okay, this is the need of bus. It gives you two advantages. Okay, now it was up to telemetry system. Now what do you mean by command subsystem? So what is the function of command subsystem? It receives the command transmitted from the earth station. It verifies the reception and execute these commands. So if you can see the examples, the first example is transponder switching, switch matrix reconfiguration, antenna pointing control, controlling the direction and speed of array drive, battery reconditioning, thruster firing, and switching heaters of the various subsystem. Okay. With the help of this command subsystem, we are able to track and also provide a command to the satellite to maintain its correct attitude and its desired position in the orbit. So this is the block diagram of command subsystem. First block is command receiver. It receives the command, then it decodes it, and that decoding information is going to be verified, and after verification it is going to be executed. And a ranging baseband extraction output is given to the telemetry transmitter. Okay, so this is the block diagram of command subsystem. So what is the function of command subsystem? It demands the verification of each command by the satellite control center before the execution. So it reduces the impact of higher bit error, coding, and the repetition of data which are employed. Okay, so bit rates for this is around 100 bits per second. For telemetry, it was 100 to 150 bits per second. Now, what do you mean by tracking system? So tracking system means we are going to track the satellite in two ways. First one is in terms of angular and second one is in terms of range. Range is measured in the kilometer. Now, the angular tracking is done with the help of one technique which is called the monopulse technique, and the range of satellite is going to be measured by simply a round trip time delay of the signal. So this time delay is obtained by measuring the phase difference between transmitted and the received signal. So in this tracking subsystem, we are going to measure the exact angle of satellite and its range. Okay. This is the block diagram of overall telemetry, tracking, and command subsystem. Over here, you can see that this is our satellite. These are our telesat stations. This is telemetry, tracking, and command station, which is providing a voice and data links from the Earth station, which are on the ground, which is having an analysis center, satellite control center, and the computer center. The data flow can be in bidirectional. So these are known as a telesat headquarters, so which provides the data communication and the reduction facility. Okay, so from the satellite we are able to measure the ranging as well as the attitude of our satellite. Okay, and based on the signal received from satellite, the data is going to be analyzed in the headquarters, and the correct data, desired data, is going to be command to this satellite to maintain its correct attitude and its correct orbit in the space. Alright, so this is the most important question from chapter number 6, that is telemetry, tracking, and command subsystem. You have to draw this block diagram if it is asked in the examination for 7 marks. These are the references. If you have any question, you can ask me at any time on this my email ID. Thank you for your attention.